Right. Welcome back, guys. The top boxes, you guys know. We have discussed it. What is tan theta? What's cosecant, secant, cotangent, and cot? Nothing new. Okay. Reciprocals of one another. I am more interested in this, guys. Okay. If I know this, I can actually derive this and derive this. I'm really interested in the last line. Okay. That's what this slide is about. So let me get rid of this. So, and bear with me a little bit here. I am just interested in these three formulas. At this point in time, I am mostly interested in the first one. All right. If this is a unit circle, guys, from college algebra, okay, if you have a, let's say this point, I'm going to just put it here in the first quadrant. Okay, it really doesn't matter. It works for any quadrant. Let's say this point on the unit circle is x and y. Okay, our equation of this circle is this. We know that from college algebra, x squared plus y squared is equal to 1. 1 is the radius. Any point on the circle, the distance between this point and the center is 1, and that's where this equation comes from. This comes from college algebra. It's called equation of a unit circle. Let's write it down. Equation of the unit circle with center at the origin. Okay, this circle is the equation. This equation, it represents the circle that has center at the origin, and its radius is 1. And this, some people write it 1 square, but you know 1 square is 1. Okay, this is something we know. We're supposed to know. All I have to do to get this equation, sine squared theta plus cos squared theta is equal to 1. X is the sine, x is sine theta, sorry, x is cosine theta, y is sine theta. I'm just going to do my replacement. And one more thing, guys, when we write sine theta squared, we put our square here. It's just a convention. Okay, it's sine theta squared plus cosine squared theta is equal to. And that gives us problem equation 1. It directly comes from the equation of a unit circle with center at origin. All right. Now, how do you get this? Well, that's easy. You divide both sides by cosine squared theta. You can do that, right? You can divide both sides by anything as long as it's not 0. So I'm going to divide both sides by cosine squared theta. Okay. I will write it here, if that's okay. I don't need this anymore. I explained it. From this first equation that we derived, I divided both sides by cosine squared theta and I got this. Well, what's that? Well, that's almost what we want. Sine squared theta plus divided by cosine squared theta is simply tan squared theta, because sine divided by cosine is tan, and the square is there, so better square it. And cosine squared theta divided by cosine squared theta is 1. And 1 over cosine squared theta is secant squared theta. Now you have the second one. Okay, again, these are called trig identities. They're true for all values of theta as long as they're defined. They're called trigonometric. They're called trigonometric identities, and they're right here, 3 of them. Now we're going to derive the third one, but just so that you know, that's what we're talking about. Sine squared theta plus cosine squared theta is 1. That means tan squared theta plus 1 is equal to secant squared theta. And guess what? I'm going to do the last one now. I do need the room, so I'm going to delete this. I'm going to delete this. This time around, guys, I'm going to divide both sides by, you can guess, sine squared theta. And if you do it on one side, you have to do it on both sides. Now, fine, sine squared theta plus sine squared theta is 1. And cosine over sine is cotangent. We knew that. I don't know why it's not going to let me do it, but we'll try. Anyway, 1 over sine squared theta is cosecant squared theta. That's the second one. Yeah, I know there were one here. Here's it's the same thing. Okay, so these are very important trig identities. We're going to use them over and over and over again in this class. Just be aware of it. We proved them. They are here. You can write them down in your notebook. It is an open book exam, so you have the formulas. So that's not bad. I'm going to pause here just a little bit to see this section seems a little long, but I would like to do at least 1 or 2 problems. By the way, by the end of today, you should be able to do the problems from 2.3. Okay, so these are trig identities. Let's go on. So these are called odd-even properties. Okay, what are odd-even properties? Okay, so let me grab this and bring it here. I'm going to get rid of this. Again, when we talk about functions, we are going to talk about odd and even functions. When you draw the curves, it'll make a little more sense. But as of now, just remember, when you have sine negative theta, what does that mean? So you have a point here. And let's say this angle is theta. And let's say you have another one here, negative theta. Because it's the same angle, but going in the wrong, or I shouldn't say wrong, opposite direction or clockwise. All right, so I'm going to say it's negative theta. Now, you do want to understand the sine values. The sine of theta and sine of negative theta will be same, but the signs will be opposite. If the first one is x and y, the second one will be x and minus y. Take a look. That's why they're saying sine minus theta is minus of sine theta. Sine theta is y here, and that's why you want to stick a minus, because it's going to be minus theta. Sine of minus theta is negative of y. What's y? Y is sine theta. That's all they're trying to say. Okay, look at cosine. Cosine minus theta, which is going to be x, and cosine theta, which is also going to be x. So they're the same. Okay, there's no minus sign coming out. And you can show, I'll show you one, why tan minus theta is minus tan theta. And this is very easy because sine is reciprocal of cosecant. Sine and cosecant work the same way. Cosine and secant work the same way. I'm going to show you tangent and cotangent and tangent work the same way. Let's work on tangent. So I'm going to prove to you that tan of negative theta, if this is theta and this is negative theta, of course my rope could have been longer and I could have been in this third quadrant or second quadrant, doesn't matter. It would work the same way. So let's try it. Tan of minus theta is equal to sine of minus theta divided by cosine of negative theta. All right. Now, based on the first two formulas, instead of sine of minus theta, I can simply write minus sine theta. And instead of cosine negative theta, I can just write cosine theta. Now, what do I have here? Sine theta over cosine theta is tan theta, but don't forget the minus sign. Done. I just proved formally that tan negative theta is equal to negative tan theta. You can do the exact same thing for cotangent. So it's again something you have to remember. Cosine function is even and sine function is odd. That's why they're called odd and even property. Again, we're going to discuss them extensively when we draw the graph. I'm going to briefly tell you right now, cosine is called even because it's symmetric with regard to the y-axis, and sine is called odd because it's symmetric with regard to the origin. You don't have to understand those terms yet. Some of you who have done trig in high school might be able to relate to it. I don't know about the rest, but we'll worry about it later. Odd and even property means these little minus signs coming in and going out. Okay, and here's the explanation on the right. I'll pause it just a little bit to see if you have any questions. Okay, guys. I don't think we'll be able to finish the chapter today, but try the problems. I think we are done with lecture. Let me grab a couple of problems, and you're going to find these problems a little more challenging. I'll tell you that. This is 2.3. Okay, let me do something like this. So again, these problems are from your text, and the ones I have assigned are similar to these. Um, I don't think I'll be able to do all of them today. I won't even attempt, but I will certainly do 2 problems from the first chunk. All right, guys? And if it kicks us out, I'm going to come back. My plan is to do at least 2 problems. All right, let's do this. Let's do the first one, and let's read the text carefully. Sorry. From in problems 43 through 58, find the exact value of each of the remaining trig functions. All right, if sine theta is given, we're going to use trig identities, okay? Let me grab the first one, and these problems will seem a little long, so be a little patient. If it kicks us out, I'll come back again, I promise you, and we will record. I think I should be able to do 1 problem before it threatens us to leave. All right, so guys, if sine value is this, and I do need my little unit circle here to keep track of the quadrants. Now, my stuff is going on here. You don't know exactly where, but you do know. Let me go back and bring my point. I'll just write it, right? Being lazy. All right, this is theta, and this is my point. So it's in quadrant 2, it's right here, okay? And I'm gonna draw my line like so. And this angle is theta. All right, guys? Now, I do know one thing, guys. Sine squared theta plus cosine squared theta is 1 from our trig identity. There are 3 trig identities. The first one is this one. So I'm going to write it down as nicely as possible. Now, I do know sine theta is 12 over 13. And I'm going to put this here because I'm going to solve for cosine theta. Now, it is a square, so make sure you get that. So I'm going to put this, square them both, because that's what it is, square. Now 12 square, your calculator will tell you is 144. I'm going to go here. 144 and 13 square is 169. All right. I'm looking for cosine square theta. Okay. I'll solve for cosine square theta. Not a big deal. Not a big deal. I'm going to subtract minus 144 divided by 169. Now, you can do it by writing. I'm going to do it the old-fashioned way. I can, of course, use my calculator. I can say this, okay? Instead of 1, you can write, you want to have the same denominator. You're going to have the same denominator. Now that we do, 169 minus 144, I think is what? 25? Yes, is 25 over 169. So cosine square theta is 25 over 169. With me, guys? I need the room. Need a lot of room. I might even use the second slide. I want to know cosine theta. That's what I'm really after. I'm going to find the square root of both sides. I'm going to find the square root of both sides. And that's going to be square root of 25 is 5. Square root of 169, you can use your calculator, will turn out to be 13. Now, don't forget one thing, guys. This is plus minus, okay? This is plus minus. This is very important, guys. Okay? Now, I don't have a good way of putting plus minus. I'm just going to write plus minus here. When you find the square root of something, it has to be plus minus. Give me 1 second, okay? Hope you can see it. Now, but we do know one thing, theta is in quadrant 2. In quadrant 2, cosine has to be negative. So I don't need plus minus. I'm going to get rid of my plus minus sign. I'm going to put a minus. And this is a subtle thing that you have to understand. The sign has to be negative. Why? Because theta is in quadrant 2. We're in quadrant 2. I don't know, and I don't care. But as long as it's in quadrant 2, I know cosine will be negative. Now I'm going to delete this. I'm going to put minus in. And this is subtle, guys. All right? You want to make sure you get it. Now that I have both, I know the sine value, the cosine value, I can find the rest. That's just a piece of cake, right? I need to find all of them. I'm going to get rid of all this. And I'm going to write it nicely. I don't need this mess. And let me write down the cosine one. That's given. Sine theta is, oh, let's be consistent. Sine theta is 12 over 13. And you want to be careful, guys, when you're taking online exams. You want to make sure when it's negative, you write negative. When it's not negative, you don't write negative. You write positive. Now, based on this, we can easily find the rest, okay? So I'm going to do cosecant right here in the same box. Reciprocal of cosine is cosecant. Secant. And I'm going to write 13 over 5. And reciprocal of sine is cosecant. And I'm going to do it in the same box. And I'm going to write 12, 13 over 12. And this is secant. I got 4 of them, right? I need 6 tangent, cotangent. Remember, guys, tangent is sine over cosine. This over this. You can cancel the 13, 2 13s. and you're going to get something pretty decent. I'll tell you what I mean. So you're going to get tan theta is equal to 12 over 5, and don't forget the negative sign. And cotangent theta is reciprocal minus 5 over 12. I wanted to tell you one more thing, okay? These sections are a little difficult, so I'm going to check my answers, okay? And I have the manual here. I'm going to access the manual, check my answer. If I messed up, I am going to, of course, redo it. So let me go back and check the answers, okay, guys? And you will be able to see it on the screen. I hope these are correct. If I mess up, I'll have to fix it. This is 2.3, number 43. Two point three, number 43. From this point forward, I'll check my answers. So it'll be a little bit of a hassle for you guys, but I think it's worth it. All right, so of course, we got that correct. Cosecant is 13 over secant. I think we got the right answers. Cotangent is 43. Okay, sine is this. Another way to do it is bring the whole thing here. Most of the time, it won't be this tedious, okay? All right, so sine is that. That's easy. Cosine, they got negative 5 over 13. That's what we got. And tangent is negative 12 over 5. That's what we got. Of course, if the first three are right, the next ones are reciprocal. They're right. So we got it right. All right, guys. As promised, guys, okay, I would like to do at least one more problem from this section. All right. So it will kick me out anytime. I'm going to, again, listen to me carefully, guys. So today we'll have a part 3. I will record part 3. Do come back. And no matter what, I'm recording part 3. Part 3 will be short. So we'll do one more problem from this section. All right, guys. See you really soon, and we'll record the session.